Hello, everyone, and welcome to week 4 of the Bevan Seminar Series. We're all super excited to hear about Éva, so I'm going to keep my comments short. Real quick, just to introduce myself, I'm Tim Essington. I am a professor here in the School of Aquatic Fishery Sciences and sundry other titles. I did want to say real quick, if you have a cell phone, now would be a good time to turn it off. If you don't have a cell phone, recommend you get one. Super handy. Do lots of things with them. And then turn it off. Yeah, exactly. Do it in that order. So it really is my pleasure and privilege and honor to be able to introduce Éva. She's one of my favorite collaborators, favorite scientists, and favorite people. She's really terrific. But I'm going to try to keep my comments as short as I possibly can because I could just rave on and on and on. So just some statistics and titles. She is the principal research scientist at CSIRO Oceans and Atmosphere in Brisbane. She holds sundry degrees from University of Cape Town, and they range in topics of applied mathematics, fishery science, and marine ecology. She's basically gone through all the same worlds that all the South Africans seem to go through if they're modelers. She's widely known in academic circles and management circles for a wide range of things. First off, a lot of people would just pin, if you want a world-class ecological modeler on your team, Éva's the person that you want to have. But I think more generally, regardless of what problem that you're working on, if you want to put together a working group, Éva's widely known as one of the brightest minds working in fisheries conservation and fisheries management, really pushing the boundaries, developing new tools and new approaches to really tackle questions that really, really matter. Also, you'll probably notice this, she's a world-class acronym generator and world-class manuscript title generator, so that's another perk. So the bottom line, if you're not working with Éva, you're missing out. I have a variety of anecdotes I can tell, but I'm just going to tell my favorite Éva anecdote. I think this was about 3 or 4 years ago, and she was out here, and she was slightly grumpy. And I said, why are you so grumpy? And she had just gotten 2 manuscript reviews back in the same week for 2 separate papers. And they were both on the same topic related to small pelagic forage fish. And both papers, reviewer 1 was, of course, glowing and said the paper is wonderful. And in both cases, reviewer 2 was an asshole, because that's the job of reviewer 2, is just to trash the paper. So for the first paper, reviewer 2 said, well, the author is clearly just a pawn of the fishing industry that's just trying to push this radical agenda. And then in the second paper, reviewer 2 said, well, the author is clearly a pawn of the environmental NGO movement who's clearly just trying to push this activist agenda. And I think what better badge of honor for scientific integrity when both sides think you're working for the other group. So I'm super happy she could come, and I'll turn it over to Éva, who's going to talk about caught in the middle sustaining fisheries in a changing climate.
Thanks, Tim. Where's this go? Anyway. Thanks, Tim. It's a bit intimidating speaking after that. I hope you're not expecting great pearls of wisdom. But good afternoon, everybody. I've met some of you, had a lovely day chatting to some of you, and hope to chat to the rest of you as well. But thank you very much for the invitation to come and talk this afternoon. It's a real privilege, and in fact, it's quite ironic because a lot of my career has been inspired from work from this very region. So really, quite humbled, really, to be with some of you in the audience today. So as Tim mentioned, I work in Australia, and today I'm going to give you a little bit of a flavor of some of that work. And Australia is a lovely place, really. It's got some unique challenges. You know, you're okay as long as you read the signposts as you go, pretty much. The areas I'm going to be talking about are largely some of the work of the Great Barrier Reef and the Torres Straits up in the north. And just to flag as well that the World Fisheries Congress 2020 is going to be in Australia, so I hope to see quite a few of you there as well. So before I begin, I just wanted to upfront acknowledge my collaborators and co-authors. So almost all of my work is done as part of large teams, and I've just listed a few key collaborators, but there are many people that I've worked with over the years. So what I wanted to do was, given there's not much I can really tell the room like this with all your experiences, give you some different perspectives from some of my experiences working in Australia. I've been there the last 10 years or so. Before that, I was in South Africa, so I'm largely focusing on the Australian examples. And I wanted to talk about some more sort of global approaches and broader ways to think about our fisheries management. And so I thought we'd start really broad with the overview effect. So this is really, as most of you will know, the sort of phenomenon that is common to astronauts when they see Earth from space, and they become acutely aware of what a fragile, connected planet it is. And I think, you know, that's a view we really need to keep in our minds. The other thing that's very evident from space are some of the inequities, for example, as shown by satellite images of lights in some regions of the world, as well as the fact that the oceans are the largest habitat and therefore clearly important for the survival of the human population as well. Incidentally, the southern hemisphere, where I choose to live, has only 12% of the human population, so we have a lot of ocean down south. The other thing that's visible from space is the Great Barrier Reef, the largest living organism, and I'm going to be coming back to that in a moment. So in terms of setting the context, I was at the Grand Canyon a couple of weeks ago, and I came across a lovely quote on sort of geological change, which sort of sets in context that there's all this natural change that's been happening for a long time on the planet and is ongoing as well. But there's also anthropogenic change, and that's certainly compounding a lot of the change that we would naturally get. And just to give you an example, 2016 was on record as having the largest annual increase ever observed in global average carbon dioxide levels. So change is happening, it's happening now, and it's happening rapidly. And we can't just keep doing our fisheries management in the same way we've always done, because there's change both in these environmental drivers, and there's change in terms of the connectedness of our global populations, which means that there are increasing pressures on things like markets, the pull on fisheries, the numbers of people wanting to access resources. So fish are really caught in the middle. To go back to my title, we've got all these environmental and climate drivers impacting them on the one hand. On the other hand, we've got all these social pressures, human population pressures, market forces impacting the fish. So what do we need to do to manage this? So we focused here on sort of sustainable future management. And I'm going to start by zooming in further into the Great Barrier Reef, and this is beautiful Lizard Island. But all is not paradise as it looks in the picture. There's some big problems. You might have heard about them on the Great Barrier Reef. One of those problems is the crown of thorns starfish. And the starfish is basically having a huge outbreak at the moment, spreading down the reef. And what it does is it eats the corals. It eats the fast-growing and slow-growing corals and is causing phenomenal damage. In fact, it's one of the three main causes of decline of corals on the Great Barrier Reef. The other two are the coral bleaching due to elevated temperatures, as well as cyclones. Why these outbreaks are causing so much damage at the moment and worse than before, there's a number of hypotheses. For example, there's a terrestrial runoff hypothesis saying that we're bringing more nutrients that enhances the larval survival, that's allowing bigger outbreaks. There's also a predator removal hypothesis, as well as some other hypotheses. So how do we come at a problem like this? And this is where these mice-type models come in, and I'll talk more about them in a moment. But really, the approach my colleagues and I have taken is firstly to pull out some of the key interactions. So rather than focusing on everything, it's a very large, very complex system, we just pull out what are some of the key interactions that we need to understand. You know, what is the role of the lethal injections where we actually divers manually go and kill these crown of thorns? Is this because we've removed the predators? Are there other things we can be doing to manage it? So these mice models help us to understand all the important interactions. We can fit them to some of the data, and we focus on a subset of the ecosystem. This is a favorite slide I like to use to explain what mice are. So this is a sort of map of some of the modeling tools we use in Australia, and they're plotted on different axes of physical complexity, biological complexity, and human complexity, where complexity, you could argue about the definition, but for example, biological complexity could be just the number of components. So at the top end, you might have models like Atlantis, some of you will have heard about, which include everything, so very large numbers of components and lots of detail. On the other end, you've got the very simple, what I call the rats, which often stop at the plankton. They skip all the top species. And somewhere in the middle is the sweet spot we call mice, where you have this intermediate level of complexity and representation of a system. So mice are increasingly being rolled out as one approach to ecosystem modeling. For example, we have a few applications in Australia. Andre recently developed a Pacific sardine example. We've been doing them in the Antarctic as well as part of some climate change projects. So just to introduce mice, because it's one of the tools that I'm going to use throughout my talk. As I mentioned, you focus on sort of more of a subset. So these models are designed to address specific questions rather than having a framework that can just answer anything. They're also designed to be a little bit more rigorous than some of the broader strategic large ecosystem models. So we try to fit them to data. We try to account for uncertainties so that you can actually provide some predictions from them which have a bit of rigor and could inform some management decisions. And you can include human and physical dimensions, as I'll be talking more about. Another really important feature of them is we try to build them with a lot of stakeholder consultations, so people talking about which linkages they think are important and how do the things interact and so forth. So the ideal way to do these models is in an iterative process. But in this case, our original mice, or should I call it a mouse, was a little bit too small for some of the problems we were trying to answer. So again, sometimes we have to go bigger, and here we've gone a little bit bigger in some of this work as well by sort of embedding mice in a bigger reef connectivity model that could sort of pick up as well the larval transport between different, in this case, theoretical reefs on the Great Barrier Reef. And then we try to link into that as well some of the factors I talked about, the bleaching, the cyclones, and so forth. So we wanted a simulation framework that will allow us to test what's the best way to sort of help the coral, if you like, on the Great Barrier Reef. Which strategies are cost-effective and likely to succeed? So we first of all validated our model by just running the basic model with some average parameters from our original mice model, and actually we got cuts, outbreaks as emergent properties of the model that pretty much resembled what we see in reality, so sort of 17-year type outbreak cycles. So we were quite confident that the coral cover and the cuts outbreaks could be used to test some different strategies. So one of the reasons I wanted to present this as an example is because, again, the sort of strategies we're thinking about are a lot broader than we normally think of in our sort of fisheries or sustainable management context. We've gone all the way from, things like, should we mitigate erosion? Do we want to reduce the nutrient inputs, which means going and talking to farmers and changing some of the land use practices? What are we going to do about some of the climate change? Do we want to develop resistant zooxanthellae that won't be so subject to the bleaching? Do we want to transplant coral? Do we want to expand our lethal injection program? That sounds awful. But or do we want to enhance our predator populations through protection or captive breeding? And each one of these strategies is really expensive and would require a lot of additional research on its own. So how do we distinguish between them? And again, this is where these sort of simulation models can help us. So in this case, just to show you one output, we compared what the percentage of coral would be in the near future and the far future under these different strategies, as well as under combinations of these strategies. So this is one way to start saying, well, where do I get good bang for my buck? Where should I invest my effort if I want to try to get the maximum coral cover, which is one of the objectives. And so, for example, increasing the cuts control certainly does have some effect, but combining some of these strategies had a stronger effect. Increasing predation, so how do we do that? Well, that was part of that original model going, we overfished some of those big predators. Has there been a trophic cascade? If we can build those fisheries, will we restore that ecosystem, for example? So the adaptation strategies aimed at reducing cuts larval recruitment turned out to be very effective in the simulations. And there were some interesting results as well about competition between the two kinds of coral, the fast-growing and the slow-growing. The slow-growing are those massive corals like brain corals. And these crown of thorns first eat the fast-growing ones, then move to the slow-growing ones. And depending on your sort of management, we found you could actually, mess up some of the balance between the two as well. So there are a lot of things you need to think about. And these sort of models can help with that strategic thinking. And really, when faced with all these challenges and changing climates and changing environments and pressures, we need these highly adaptive strategies. And we need to pre-test them. So one of the tools we typically use to sort of pre-test which strategies are likely to fail and succeed and do really well is using a tool called management strategy evaluation. So it's really like using crash test dummies. So you're trying out, is a strategy going to crash and fail, or is it going to be a good strategy? So that's another of the methods that we use in a range of examples in Australia. And one of these examples, again, is the sea cucumber or beche fisheries. So I'm not sure how many people know about sea cucumbers, but they're economically highly valuable. They're mostly exported to Asia, where they're pretty sought after. There's a range of different species. But around the world, many of these have been overfished. So they're quite easy to overfish because they're sedentary. You can just go and pick them up. They're often close to the shore. And some of the highly valuable species, they're sort of big and slow-moving, and people can fish them out quite quickly. So how do we deal with something like this where we've got market pressures? And you can see from the catch history, for example, this is showing you different species, the change in the catch over time. And that's because of a number of things. The first, the green one there, is because that was one of the more valuable, the black teat fish is one of the first ones that's usually fished out because it fetches the highest price. Then some of the other ones like prickly red fish, I think this is a white teat fish. This one here, a burrowing blackfish, that's a new species where they've figured out the processing, got a new market going. So you've got these changing market pressures and drivers and demand, which then change what we see in terms of our catch composition and the pressures. At the same time, you've got environmental factors affecting these fisheries. So how do we come up with strategies which are resilient to some of the changes out there in order to do sustainable management? And it's one of the topics that I'm sort of focusing on today is, what kind of tools do we need to use, and do those tools work under all of this change that we're experiencing, both sort of socio-political, market change, as well as environmental? Because a lot of our classic fishery science has been more sort of equilibrium type models. So with the sea cucumbers, we not only have all these economic drivers, we also have large uncertainties about the actual biology of the species. They're also hard to monitor. I like to joke that, how long is a sea cucumber? You can pull them any length you want. It's one of the reasons we don't really have size limits for them, or you try to measure it and it disintegrates or shoots some glue at you. They're pretty challenging, or you try to count them and they're all under the sand, and an hour later they're all out. So there's a lot of challenges in working with sea cucumbers, and it's one of the reasons we don't have these sophisticated stock assessment models we have for some other species out there. So it's a great species to do sort of management strategy evaluation on, where we can take account of some of these uncertainties. So this is more formally what management strategy evaluation looks like. We have an operating model that includes all the biology. You can link in economics and social cultural things. And then you pretend that's the real world. So pretend you've got the whole world captured there. And then you take different strategies and you test them. You see how well does it test, and you evaluate how well it tests. And you evaluate those by comparing performance indicators. So this could be biological, economic. It's usually just biological, maybe a bit of economic, but it can be social and cultural too. And then you look at the trade-offs between these, and you do this with stakeholders in an iterative process. And that gives you an idea of which strategies perform well and which have some problems you might not have anticipated. So in this particular fishery, we had, there was some sensitivity on the Great Barrier Reef to the fishing of the sea cucumbers. And because there were some concerns about local depletion, the fishers themselves instituted a spatial rotation strategy, which they said was a common sense thing. Surely that was going to help. But the management authority wanted a more rigorous way to say this is working, or we need to modify it a little bit. And so this was where we came in with a sort of this modeling of all these sea cucumber populations and a management strategy evaluation approach, saying, well, let's try out some different strategies and see how well they perform. And to skip a lot of detail, basically, some of the final ones with the numbers here were, this is if you fish them every year, this is every second year, every third year, and so forth. So different spatial rotation strategies. And we looked at what is the risk to the actual resource, averaged across, in this case it was across 8 different species with different life histories and distributions, as well as the revenue. So how much would you actually make? Because the different species have different values. And some of the lower valued ones are quite abundant, so you want to take that into account as well. And actually it turned out that the 3-year spatial rotation strategy that industry had just suggested from their own experience was a real winner. And so that just provided some validation that that was a good sustainable strategy. So quick summary, where are we in terms of all these models and modeling under changing environments and conditions? So far we've talked about this need to sort of extend our toolbox of approaches, and one of the methods that we've used is so-called mice. With our ecosystem models in general, just a note to any keen students out there, I think there's still a lot of work that needs to be done. Apart from not necessarily having the data, we need to validate these models. I don't think we've done enough sort of theoretical analyses and understanding of the models. Quantifying uncertainty is still a key challenge. Under climate change with our models, a lot of our fishery stock assessment models and even these mice models, we do them beautifully fitting to all the historical data, and then we pin down from that all the relationships that we can use to project forward. But with climate change, with things changing so fast, that actually falls over because we don't actually know what's going to happen in a lot of cases. And this is one of the reasons we need to sort of check across a range of uncertainty that captures a range of plausible future outcomes. So a lot of these models, we have to move a little bit away from just narrowly pinning everything down to the data and what we saw in the past, and we have to be prepared to say, well, what if the future looks like this? Will the strategy still work, or is there something that might be better? And that's one of the ways we're increasingly using our models. And as I mentioned, management strategy evaluation is one of the tools that we also use to look at these trade-offs between how different strategies work. So that's great. That gets us something that tells us a good way to have a sustainable population of a fish. But what happens once you land that fish or that lobster? And this is where the supply chain comes in. And this is one of the areas I've been trying to push, that to do sustainable fisheries management, we increasingly need to look at this aspect too. So, for example, consider up here in the Torres Strait landing your lobster. So we could say, job done, I've worked out there's lots of lobsters there, and this is how many you can catch. We can all go home now. But really the process doesn't stop there. You've got this whole sort of chain where the lobsters, are caught and they go to holding facilities and they're transported, and eventually they end up with your consumers. And that particular chain is what's called the supply chain. And supply chains are not unique to fisheries. You get the same sort of thing in, for example, other primary industries like agriculture or mining, where they've got the same chain. And in the same way, in our ecological models, we look at, where are the vulnerabilities? If I catch too many forage fish, am I going to have no seabirds? In supply chains, we have some similar things, looking at where are the vulnerabilities and how do I come up with a resilient supply chain? Because really what you want is you want this lobster here to end up all the way where you want it to go, and you want to get the best economic value for that. And this is another lever that we can actually use to help manage some of our fisheries. We also need to acknowledge that climate change can increasingly impact any of these stages, and I can give you heaps of examples. You know, for these industries, floods and things have had major impacts, and there's some good global examples. In fisheries, we've had problems with, you know, red tide stopping the production of lobsters, and then you break all those links. So on the other end, your buyer is not getting any product from you, and they're going to start looking elsewhere. It's really bad to break a supply chain, for example. So we need to think about that sort of thing. And we need to think about it, as I said, in the context that actually the fish are sort of in the middle here. So it's not that the fish are the end point. You've got this whole ecological chain with all of the vulnerabilities and climate change affecting things here. Then you get the landed product, and then you've got vulnerabilities and things all the way through your supply chain. So we can map those supply chains in the same sort of way as we map food webs. And we also get simple food webs and complex food webs, and we get simple supply chains and complex supply chains. So we can use some of the same sort of methods that we might use in food webs. And to give you an example, a lot of the supply chain literature is very qualitative, whereas modelers always love to make everything quantitative. So when I started working on supply chains, the first thing we did was, you know, we try to structure it. Let's break them up, put them up as networks, and let's use some metrics to analyze where the vulnerabilities in the supply chain and which supply chains are really resilient and perform well. So for example, I've got this quantitative index called the supply chain index, which highlights domestic consumers and supermarkets as being your key elements in a banana prawn supply chain. So that gives you a heads up that those are areas where you might want to focus to build your resilience if you want that supply chain to function efficiently. We can also compare supply chains for different fisheries and say, well, which one is actually better, and can we learn lessons from that to apply to different fisheries? And we can take it further, as my colleagues and I did in this example, where we use the same methods for fisheries examples as well as agriculture and mining. So we modeled a diamond supply chain, which was really fun. But in all the examples, we managed to show that actually the complex supply chains were more resilient to shocks and extreme events that we're going to increasingly suspect under climate. And why is that important? Well, it's important because this economic rationalization has driven a lot of our science, supply chain science, and as I'm saying there, it's also driven a lot of our sort of food web thinking in many cases. So the idea of supply chains, if you read the literature, is that they need to be really streamlined and linear. But of course, if you think of the simplest example, really linear supply chain, and a flood or something knocks out one link, the whole thing breaks, right? Whereas if you have a more diffuse, complex structure, you have alternative paths. So there's a bit of a trade-off, advantages and disadvantages. It's not as simple as I'm suggesting. But this does suggest that complexity can be good in this context. And as I said, I've analyzed it in the same sort of way we'd look at a food web, and I would argue that, and I think a lot of people do argue, that complexity in food webs is a good thing too, increasingly as we need to face more and more change, because it does add to the resilience of systems. So I think a classic example is the Gulf of Maine on your doorstep, and I love Bob Stenick's comment that really it's become a domesticated ecosystem, sort of similar to agriculture and things. And you know, that's great. So we've got lots of lobsters there and not much else, no more fish and that. And is that good? Well, you could say it's great. It's really efficient. It's economically, it works. Lobsters are really tasty. We'd rather eat them than herring, for example. But what are the negatives? Well, one of your big negatives is that you lose the resilience. So you've simplified this to be more like an agricultural system, but it comes at the cost of you sort of cutting short your future options. And as climate change increasingly, for example, affects the distribution of those lobsters, are you going to have any backup options? And I think this is something we increasingly need to think about, because a lot of our thinking has been towards sort of optimizing things and streamlining things, But we're going into a new era where resilience is increasingly important. I'll give you one brief example from one of my mice models, back to mice. And this is from an abalone urchin lobster mice model developed by PhD student Laura Blamey. And essentially this tried to look at the question of a regime shift occurred in this Benguela system of South Africa, and has overfishing altered the system resilience? So briefly, in this system, is a rock lobster invaded the system due to some environmental effect. And the rock lobster ate all the urchins because it loves urchins and, preferentially picks them out. So no more urchins, but the juvenile abalone shelter under the urchins. And so the juvenile abalone's survival plummeted. At the same time, the abalone population was subject to illegal fishing as well as legal fishing. And so you had a whole shift in this ecosystem. And so we were wondering whether, if there was still abundant fish in the system, would this have happened? And so again, we did some simulations in the first case where we showed, well, with the overfishing scenario, because we know the fish there are pretty overfished in that system, the lobsters invaded, they depleted the urchins, changed the benthos, and the system crashed. But when we simulated high fish abundance, and in fact we went down to about fish being at about half of the carrying capacity. If you'd maintained them at, say, half of the carrying capacity, we found that the fish would have kept the invading lobsters in check, and your system might have been resilient to this change, and you might have prevented a regime shift. So what are the lessons from that? Again, it's using these models to help us prepare and plan ahead for some of these changes. I think resilience is really important to think about, and these multi-species and ecosystem models can certainly help us understand the responses to perturbations, recovery times, how to increase the resilience. And certainly I think there's some examples that both complex food webs and complex supply chains can be more resilient. So a couple of tips for the students in the audience: think big and think complex. I think we need to transition a bit from these concepts of just focusing on optimality to thinking a bit about balance and resilience. And also don't be afraid to look at other disciplines. Are there tools there you can use, or can you trade some of your own tools? So coming back to one of the questions I posed, when do modeling approaches succeed or fail in a changing environment? Thinking of both environmental change and changing sort of socio-political and so forth. We've talked a bit about we need to consider climate change and adaptations. We can't ignore things like supply chains and market forces, because these go all the way back down to sort of driving the fishing effort that we actually see. And so if we ignore them, we're ignoring an opportunity to sort of have another lever to help manage a fishery sustainably. But one of the main ways that our approaches fail is if we don't communicate adequately. So even the best, most beautiful model fitted perfectly to data is going to be pretty useless if you don't get buy-in from your stakeholders and you don't communicate what you're doing. So I wanted to just take a little detour to one of the areas where we spent a lot of time communicating with fishers and listening to fishers. And this is the Torres Straits, right up as I showed you in the north of Australia, where the Torres Strait tropical rock lobster fishery is economically the most important fishery to the indigenous stakeholders in the region. So we call them traditional owners in the Torres Straits. And the Torres Straits Treaty explicitly states the need to acknowledge and protect the traditional way of life and livelihood of the Torres Strait Islanders. So we've got it explicitly as a management objective, and it's something we need to think about in doing our fisheries management. So just from a technical perspective, and I know a few of you have seen this before, so I won't go into it in detail, but one of the ways we've done that is by, again, broadening our modeling framework. So our sort of classic modeling framework with a biological model at the center with spatial lobster populations, we link to some economics and cost structures. So that's sort of what you'd think of more as a bioeconomic model. But then we wanted to include these very important socio-cultural factors as well. And so we did that in two ways. The one was with social analyses, so for example, from structured social interviews, we collected a whole heap of very valuable information, but it wasn't stuff. Much as I tried, I couldn't turn it into numbers. So we had to work with qualitative information. And that's often one of the challenges why we ignore it, because we can't quantify it and therefore it doesn't fit in our model. But we did retain it sort of in parallel and brought it down. Some of the social stuff we managed to do sort of semi-quantitative stuff, and we integrated that into the model. But then when we linked all of these and we looked at how do different strategies perform. We looked at not only biological indicators, so like the stock status was good, yes, economics, we looked at different subsectors, how are they doing, but we also brought in social cultural indicators. So we said, well, if we do this particular strategy, is it one that will be considered equitable? Is it consistent with custom? All the things that emerged from the stakeholders themselves as important to them and objectives that they wanted to achieve. And interestingly, just to give you one result from that, two of the social indicators that emerged as really important from the few of the islands wherever we went was that ownership and equity were really critical drivers. And I think that applies to most fisheries globally, actually. So we spent a lot of time working with stakeholders to try to genuinely engage with what was important to them, not just economic returns, but also their lifestyle, their livelihood, their social cultural practices. We've also been engaging closely with them in terms of we're currently developing what's called a harvest control rule, which will sort of take data from a survey, plug it in a formula, and help set what the quota should be. But we've done this in a very collaborative way, working with our stakeholders, getting their inputs, and we've used a range of communication tools. For example, we have a graphic artist who sketches summaries like this as we go to help translate some of my equations and things into a more easily understandable format. So we have spent a lot of time communicating with our stakeholders, and although initially we didn't always have great buy-in to our science, I'm sort of quite proud to share really that after a number of years of working closely with these stakeholders, we've now got some really good buy-in, not only for the lobster, we're also doing a harvest strategy for the beche, what they call BDM fishery. And again, the stakeholders are actively engaged in that. And so I thought what I would do, during one of my working group meetings, I actually just asked a couple of the stakeholders if I could do an impromptu interview with them. And rather than telling you what they thought, I thought I would show you a short video from the really remote Torres Strait area. I hope the sound works. Is that sound working?
Thanks, William and Michael. Just wanted to ask a couple of questions about your life in Torres Strait and the fisheries that are so important to you. Do you see a role for science in supporting the fisheries management?
Yeah, I see there's a potential there for science in the Torres Strait, especially in the fisheries industry. With CSIRO working with us, and as part of the community is for the community to be educated on the science part of our fisheries, so they can better understand and how the fishery works throughout the Torres Strait. So I think it's good, like we have the partnership together, like with all the divers and the fishermen from the islands, working together with the scientists, CSIRO guys. It will be a good partnership to form a better management plan for sustainability for Torres Strait fisheries.
The same for me too. What you say, you speak for all.
I think working in partnership is such a key role for the industry and the scientists working together to ensure that everybody is aware, and especially the industry, to understand how important the scientist data that they provide to us will be able to help us to maintain and sustain the industry of us in the Torres Strait region.
It's a partnership in marriage, I believe, in the Torres Straits. Science with CSIRO, I mean, the legacy speaks for itself that, where science has been involved, there is sustainability, especially in TRL and other fisheries, and now with BDM fisheries. And I think, we must engage for the future, for the better of the fisheries.
Yes, I think that's very important, having the science report in regards to helping us out to be able to manage this industry up here, because to ensure that we don't overfish all these different species that we have right across in the fishing industry.
And just one more question. So, do you have any concerns about climate change affecting fisheries, or have you noticed any changes here in the Torres Straits?
I think some of the changes have been, the coral bleaching is one of the main issues at the moment in the Torres Strait waters. We've seen a few changes on the reefs, especially with coral bleaching, and also there's temperature changes in the water.
The rain, it seems to don't like, they're not like normal. So we need more data to let us know what's in 10 or 50 years time going to be like. So we like to do something now to, grip ourselves properly.
I think it does have effect in certain parts of the Torres Strait, and the temperature of water, especially in the Malugal and Malugal Nation.
What's the most important thing to you about managing a fishery?
I think the most important thing for me is to ensure that there is fisheries, the management and sustainability of our fisheries in the Torres Strait region is there for our future generations.
I think it's about getting to understand that the changes we need to adapt and adopt to in terms of business, and that this is the whole part and parcel of the harbour strategy, and that it's for the future that we can engage with the market in the global village.
Because without the fishing industry, we wouldn't have a backbone to survive here in our region.
So hopefully, you're as impressed as I am by the depth of the understanding of the need for science, the role for science. It took a while to communicate that and to listen to what they thought as well. But just a few sort of summary words that some of the stakeholders brought out. But again, in a region like that with very many islands over a large area, implementing some sort of management strategy without the buy-in of the community leaders on the ground with people in different communities is going to fail. So again, I can't stress enough the importance of communication if we want our strategies not to fail. And certainly the stakeholders were very acutely aware of change all around them and the importance of that change and how they can use science to adapt and do better. So we've talked about communication and stakeholder buy-in being key. One of the other topics I had to briefly touch on is, approaches fail, again, doesn't matter how grand they are, if we don't have a social license to operate. And certainly in Australia, this is one of our huge issues. Our aquaculture industry in Tasmania currently battling with issues of social license. Many of you might know from the news that there was a sort of social campaign on Facebook which ground to a halt the super trawler coming and fishing on our pelagic fishery. And so social license to operate is another really important factor that we're increasingly needing to think about, because it's something that's important to the public out there, and the public can organize themselves very quickly and have a very, very big voice. And so how do we address concerns of social license to operate in an objective way with sort of science to back up some objective decision making? It's also linked to and compounded by some of the ecosystem considerations. So things like in the case of forage fish, concerns about the needs of predators. And so again, there have been a number of groups, and many of you work as well on forage fish and looking at how do we account for the needs of the predators in their system. So again, these are things we weren't doing a couple of decades ago, but increasingly they're important, and they're important not only in terms of the ecosystem stuff, but also to get that sort of social acceptance of different developments. So just briefly to think about what we're trying to achieve in sustainable fisheries. So hopefully most of you are familiar with the sustainable yield curve, sort of saying, you know, if you have a fishery at carrying capacity, larger numbers of individuals, down to sort of none or one, as we decrease, there's sort of an optimal level, which we call the maximum sustainable yield, which gives you the highest possible sustainable yield from that fishery. And that's the target in many fisheries, and certainly here in the US, it's a very important target we aim for, even though the curve, you know, can look a little bit different to this. In Australia, we tend to focus on MEY, the maximum economic yield. So the focus there is on trying to optimize your economic yields, with the theory backing it up, saying that's actually a slightly more conservative reference point or target to aim for. But where do we fit in some of the things I've just been talking about? Well, that complicates the picture. So these are really equilibrium concepts, and sort of part of what I've been saying in my talk is that our equilibrium concepts are increasingly being challenged. You know, we need broader approaches to address some of the ecosystem approach to fisheries moves, for example, and socio-political changes that are occurring, changes in values as well. So how do we bring those in? And I certainly don't have the answers for those, but I just thought we'd get you thinking about it, because we've got some bright students that can solve this. And for example, our ecosystem sustainable yield over here, from studies like the Lenfest study I had on the previous slide, looking at, you know, how do we account for the needs of predators like seabirds when we harvest forage fish, it suggests that you need to keep the stock at a higher level. So we sort of shift our target a bit to the right here. What about what I call, where do we get maximum social satisfaction? So if anybody has the answer, please come tell me after the talk. But I'm just, again, throwing it out there that, you know, MSS can include all sorts of things. It can include your socio-cultural considerations I talked about, aesthetic considerations, recreational fishers also want to have fish close to shore that they can catch, as well as what I talked about, climate change resilience. So that work was showing, well, maybe you need to keep, you know, some species at higher levels so that you maintain the resilience, which is a better long-term strategy. And so exactly where it is unsure, and as I've indicated, these two together, not surprisingly, make messy. And this is an area where a lot of people are trying to do some work. There's also, you know, you could start bringing in where's the social license to operate. You're probably doing better down here than you're doing in this area over here. So again, how do we start folding all of that into our fishery science? I had to put one equation in, so I chose the simplest one I could, because not everybody loves equations. And that's thinking about, you know, all these changes I'm talking about. What does it mean for some of our sort of conventional fishery models? Well, let's just take a very simplified example, like your fishing mortality. You could think of it as your catchability times your effort. So how many people there are or how many boats is going to influence what your fishing mortality is, what proportion of the resource you're going to take. And then your catchability, so how easily you can catch it, or your fishing power, if you've got a much bigger, faster boat, that can also influence what your fishing mortality is. So these two things are going to influence your fishing mortality. But if we tease them apart, talking about change that's happening, the problem is that a lot of our models are really linear, and these things are all non-linear, and there's all these exponential things going on. So everywhere I look, like here's the human population growth, right? So the numbers of people growing exponentially. So effort, if you just left a fishery, effort is not going to just increase linearly, it's going to increase exponentially. You can have a gold rush effect. You know, you find some valuable resource like a sea cucumber, everybody's going to rush and want one. So again, effort is going to increase exponentially. You've got fishing power and things which often increase exponentially as well. And then you've got nonlinear relationships between supply and demand, for example. A great recent paper sort of explaining some of that. For example, as the abundance declines, the price goes up, and you get these non-linear relationships between supply and demand. And so on the right-hand side here, you've got all these non-linear, non-static things, and things like shooting through the roof. And it's no wonder we have a hard time holding this steady. Because holding this steady is shown to be quite a good strategy, right? If we can get that right, we're doing okay. But it's no wonder we mess it up some of the time, because I think we underestimate the rate of change on the right-hand side. And it's just a very, very simple example, but I think it's the sort of things we need to think about increasingly. How are these nonlinear things feeding into our models? So just quickly to sum up some of those models, we need evolving models, or like the little mouse there, they're going to become endangered because they'll become redundant. Nobody's going to want a model that doesn't include all the important things anymore, and what's important is changing. We have to think about climate, we have to think about these broader drivers and things as well. And one of the ways we're sort of evolving our mice is we're trying to start dynamically building this two-way dynamic feedback between natural systems and human systems. And we're using a sense of place index to try to say, that can draw people to an area or send them away, and that can change a fishing effort. And so you get all these nonlinear feedbacks through a system. So it's one way we're busy developing these mice models to try and make a start at some of this. And certainly there are a number of groups working on approaches to this. So we need to keep thinking about, what can we do and build onto our current models. So lastly, I thought we could consider a big example, a big complex example, and that's one on whaling, right? So whaling has all the things that I've just talked about. I mean, economics were really important. Whaling actually first declined because of the invention of the oil well, but at the same time there was a serial depletion from the larger species down to some of the others, which was linked to biology and fishing. Social values have changed over time in terms of whether whaling is acceptable or not. The global concerns, it's sort of in the bigger picture of worrying about forage fish harvesting, and are we leaving enough krill for the whales if the krill fisheries keep growing as they're predicted to be. And then there's all these climate impacts, and this is quite a linear chain going from sort of krill to whales and that. So if we knock out the krill, well, what are the whales going to eat? In our southern hemisphere, they eat almost exclusively what we call Antarctic krill, Euphorsia superba. So there aren't herrings and things around for them to eat. So just to give you a flavor again of a sort of bigger mice model, this is a model as part of Dr. Viv Chillock, recently she's doctor, part of her PhD thesis, where we did a sort of mice model linking 5 different southern hemisphere baleen whales to krill and copepods, and in turn linked that to a sort of oceanographic model with phytoplankton and some oceanographic drivers. And the way in which we did this, we built up the model in a sort of stepwise process. So we start with just looking at the impacts of the historical fishing on the whale populations. And the blue bars are the catches from, for example, 1890. And note that they're on different axes to the population trends. It's just to show you, for example, very large catches of blue whales here. And these trajectories are the decline in the blue whale population over time, and then we have some forward projections. So you can see that for many of the species, for example, the blue whale, the fin whale, the southern right whale, the historical harvesting drove the whale population to very low numbers, and in fact, the recent paper suggests that even by 2100, some of them won't have recovered to sort of half of the pristine numbers. Other species like the humpback whale are predicted to be bouncing back quite quickly. But the idea of this modeling was to then build up, what if we just took into account no interactions with the prey? What if we took into account bottom-up interactions only? Or what if we took into account sort of climate drivers on the plankton? For example, changes in sea ice and temperature going to affect the plankton, going to affect the amount of krill. And we did this in the 2 oceans, the Atlantic and Indian, where we got differences for not only different whale species, but how they do in the different oceans. And some of this work is some of the recent climate projections are currently in prep, so I'll just give you a flavor of it, but the important thing here was that, for example, for the humpback whale, where we're predicting quite a good recovery over the next century, when you bring in some of these climate drivers, even though there's a lot of uncertainty and it's not going to be dead right, but that can turn over your recovery trends again. So we need to be thinking about these things in our models and in our management. Just looking at controlling the fishing levels, in this case the whaling levels, is not an adequate solution on its own. The whales still have a number of challenges. So these strategic dynamic models can certainly help provide improved understanding, and just to stress that many of these big whales are still recovering from that historical whaling. And the future climate stresses are predicted to impact the different species differently and in the different ocean regions as well. So finally, just a quick to-do list for students. Remember, fish are caught in the middle between non-static inputs and outputs. You're going to increasingly need to integrate your research on climate impacts. You need to consider some broader conservation goals as you move into doing more modern science in the Anthropocene. Very strong message to always support data gathering and use. I don't think we have nearly enough data. We've sort of moved into an era where modeling is cheaper and easier, and in many regions we're not actually collecting the data that's going to help us inform these new changes we've never seen before. We can't just rely on data from the past because some of those relationships are going to change. And then, as I try to stress with my video, really encourage you, even though it is difficult, it's time consuming and it's hard, but you do need to communicate with and listen to fishers if you want your science to be relevant and applied. So on that note, just to say thank you again to all my co-authors. Thanks very much.
We do have time for a couple questions before we have our informal Q&A out in the lobby, so I'll let Éva call on her favorite question giver.
Can you expand a little on the sense of place index or other indices that characterize like the bioeconomic system and the social cultural system in the mice model, and like what factors go into characterizing those?
Right, so we are still working on that, and it's been rejected 3 times, I just have to say, because biologists and stock assessment scientists don't like it because they go, oh, you haven't quantified and validated this, and social scientists don't like it because they go, you've misused our term sense of place. And so we're still trying to find a sort of happy sense of place for these models because I think they're really important. And we're trying to look at ways to actually get some data because I think there are ways we can do it. But it's things like the example I like to give is one of our sort of case studies is, do I build a fish processing factory or do I enhance tourism in an area? And you could go, you could play out scenarios of if I build a fish processing factory, how will people move to the area? They'll move there because there's jobs and whatever. But then there's feedbacks between if the environment deteriorates, it's like we've got the sense of place index will deteriorate and that will drive people away again. And so that can pull pressure away from fishing. So it's that sort of two-way feedback that we're thinking about incorporating. And we've got a suite of indicators that we're trialing saying, well, cultural considerations are important, the sort of aesthetics are important, employment's important, and we're trying to work on an integrated index. So we don't have the answer, but very happy to hear any views on that. It's something we're trying out. Yes?
Hi, so I'm a communications graduate student, and I really enjoyed your video.
Thank you.
Hearing from traditional owners. So my question, since you had such success with your communication, what are some of the strategies and methodologies that you employed to achieve that success? And were there any failures along the way, and are you willing to talk about those a little bit?
Yeah, I mean, it's a hard one giving people a sort of list of what works, because I think what works is wanting it to work and putting in the time and energy, because it does take a whole heap of energy. So when I first started working in that region, admittedly there were some other political pressures, so we didn't have a very good relationship, and people would walk out and shout at one and tell you you knew nothing. And it was about building that sort of bridge and that connection and showing how the science actually works. It was also, because we were doing the assessment, it was actually validating, saying, well, here's what my model says is going to happen. And every year the fishers would come back and say, oh, you weren't too bad, that was right. And I was like, thank you, I take the credit for all the lobsters. Or, it was that sort of actually showing that you were getting some of the science right. So it was first building the trust. And then once we got that trust, and then it was the language and communicating. And so with communication, and I think it's not only Indigenous people, I think it's everybody that likes stories. And so we try to tell things in a story. Where are you trying to go? What are you wanting to achieve? And that's some of those sort of graphic plots as well. We try to do it as a story of what would you like? I mean, some of the goals were quite hard, 100% ownership, but how do we get there? How do you get sustainable fisheries? How do you reduce your risk? So a lot of the, technical terms we use, the fishers understand all of that. It's their life and it's their risks, and that they just use different language. And so it was about communicating without all the jargon. So we wrote some simpler brochures. We talked, and often in the meetings I'll explain something, and then I'll explain it 5 different ways until sort of most people have got it. So it's a lot of effort and time, and I realize we can't always do that, and it doesn't work in every fishery. And it's a process. I mean, it's taken a few years, and as I say, like those fishers, I literally just said, what do you think? And I was like, wow, they're speaking the lingo, talking about harvest strategies and climate change and all of these things. So that comes from a few years of actually just talking and listening, importantly, listening.
Well, we are a bit over time.
You want to go, Andre, or the back? There's one right.
I suggest that we formally thank Éva and then continue questions over